Hello. In today's live stream, we are going to start chapter 3, equations and inequalities. Just before I do that, I am going to go back and do the challenge that I talked about at the end of the last session. So remember, we're talking about quadratics and we're talking about modeling quadratics, and this was the challenge at the end of that section. That's what I'm going to do right now. It says accident investigators are studying the stopping distance of a particular car. When the car is traveling at 20 miles per hour, its stopping distance is 6 feet. When the car is traveling at 30 miles per hour, its stopping distance is 14 feet. When the car is traveling at 40 miles per hour, its stopping distance is 24 feet. Hello, VK. The investigators suggest that the stopping distance in feet is a quadratic, d is a quadratic function of the speed in miles per hour, s. Okay, so a bunch of information there. A says, given that d of s is equal to as squared plus bs plus c, find the values of the constants a, b, and c. And they actually give you a hint over here. Okay, so let's write a few things down here to summarize some of this information. Firstly, the function. I hope I have enough room. I might need an extra page. The function is as squared plus bs plus c. And we don't know any of those variables, but they give us this information. So at a speed of 20 miles per hour, which is s. So s equals 20. The stopping distance, which is d, is 6 feet. So we could create an equation in terms of a, b, and c using that information. So we could say that a multiplied by 20 squared, plugging these into this function, plus b times 20 plus c is equal to the stopping distance d, which is 6. And then using the other piece of information, we're going to be able to create 3 equations that we can solve for a, b, and c. So using s equal to 30 and d equal to 14, we can say then that a times 30 squared plus b times 30 plus c is equal to 14. And here, I believe we have enough information already to solve for a and b. But let's see. So let's call this one equation 1 and equation 2, and then let's subtract equation 1. So this would be a times 20 squared plus b times 20 plus c equal to 6, and we're subtracting these. So this would be 900, take 400a. So what would we get here? We would get 500a plus 10b. The c's would cancel. That's kind of the reason why I did it. Oh no, this is not going to allow us to solve anything, but it's going to give us an equation in terms of a and b. 14 take 6 is 8. Okay. And then using the other piece of information, I'm definitely going to need a bit more room here. Okay, so using the other piece of information, we can say when the speed is 40, the stopping distance is 24. So then a times 40 squared plus b times 40 plus c equals 24. Again, just plugging everything into that function. And now we could create another equation in terms of a and b. So if I call this one equation 3. This is in terms of A and B. And this is equation 4. Lots of different equations here. And this is actually leading into the next section because we'll be talking about solving simultaneous equations. So this is kind of a lead into that. Anyways, which one is best? I could use either 1 or 2 really here. Although if I use 2, then it will, sorry, if I use equation 1, it will give me the same equation back out. Or will it? So 40 squared is 1600. Take, well, yeah, it doesn't really matter. Let's just do equation 2. So let's subtract equation 2 from this. So the equation 2 was a times 30 squared plus b times 30 plus c equal to 14. And if I subtract these two things, that's 1600 take 900. That is 700. Hi Philic. 40 take 30 is 10b. The c's cancel again, and 24 take 14 is 10. Okay. Now I have, actually this is handy because I have a 10b in equation 3. And if I call this equation 5, then I can subtract these two. That will eliminate the b, so I'll be able to solve for a. So let's do now equation 5 take equation 3. These are the two equations we created out of this information. Is the mic okay? Can everybody hear me all right? So 5 is 700 a plus 10b equal to 10, and equation 3 we're subtracting. This is 500a plus 10b equal to 8, and subtracting these we get 200a. Okay, cool, thanks for letting me know. Cheers, appreciate it. 10b take 10b is, they cancel out, so then we have 10 take 8, which is 2. So a will be 2 divided by 200, 1 over 100. I might write that as a decimal. So this will be 0.01, that's 1/100th. Okay, so I have a value for a. I can also solve for b now using any of those equations. So let's just use equation 3. So plugging this back into equation 3, we would have, oops, wrong color. We would have 500 multiplied by 100th, that's just going to be 5, plus 10b equal to 8. So 5 plus 10b is equal to 8. Oops. And then 10b is equal to 3. 8 take 5. So b is 3/10 or 0.3. Okay, I have my values for a and b, so let's have a look at the original function again. This was a 0.01 s squared plus b 0.3 s plus c, and we could go ahead and use one of the original piece of information to solve for b. So if we go back to equation 1, they told us that when the speed was 20 miles per hour, the stopping distance was 6 feet. So now we have a, now we have b, we can solve for c. So let's write that down. This was equation 1 again. So now we have A, which is 0.01 times 20 squared plus 0.3 times 20 plus C equal to 6. This would be 400. 1/100th of 400 is 4. 20 times 0.3, that's like 20 divided by 10 times 3, which is 6, plus C equals 6, so therefore C equals -4. Okay, still need a little bit more space. So now I have my values of A, B, and C. And well, that was part A. Done. And then part B says, at an accident scene, a car has left behind a skid that is 20 feet long. Use your model to calculate the speed that this car was going at before the accident. So now they have given us the stopping distance of 20. And we have our function. So let's write down the function in full. This was 0.01 s squared plus 0.3 s plus take 4, because C is a negative. Take 4. So this is part B, and now we know the stopping distance. This is going to be solving a quadratic, basically. So we're going to plug in 20 for D. Then if we take that 20 from the left hand side, this is -24 equal to 0. And I wonder if we could factorize. So if I multiply everything by 100, I would get this. So I just multiply by 100 there. And are there factors of 2400 that make 30? What are the factors of 240? 2 times 120, 3 times 80, 4 times 60, I'm not sure. Maybe you can factorize, but I am just going to stick it into the quadratic formula for now, so I don't waste too much time. So this is -b plus or minus b squared take 4ac all over 2a. -30 plus or minus, oh actually I might go back to the decimals for this. Oh well, why not? Doesn't really matter, I'll be using the calculator anyway. B squared is 900, take 4 times A is just 1, B is -2400. Oh well, 2, and then that's divided by 2. Yes, Edexcel. This is an Edexcel textbook anyway. Okay. Let's just grab, actually what is this in here? 900. Okay, yeah, let's just get a calculator. Why bother doing anything else? So 900 plus 4 times 2400 10,500. That is not a square number, I don't believe. No. 0.9. Actually, I'm going to go back and use the decimals instead. I feel like, I don't know, I just feel like that's going to give a nicer answer. So b was 0.3, b squared 0.9, sorry, 0.3 squared. Is that 0.9? 0.09, yeah. Take 4 times a times negative 24. Okay, then we get 0.9 plus 4 times 24, 96.09. Okay, there's not going to be a neat way to do this, I guess. And this has to be a positive because we can't have a negative speed, so we're only yeah, it's just going to be the same. I thought maybe it'd simplify to a nice surd or something. I don't know why. I don't know what I was thinking. But so we're using the positive root because we're talking about speed. So we're going to take the square root of that answer and then subtract 0.3 and then divide by 2 and that's clearly wrong. You know what I should do is probably check these. Okay, actually, let's just assume they're correct for now. And let's see. So basically, 4.75 I don't think is the speed because that's just too slow. So I'm assuming I made some error here. 96.09, the square root of that, take 0.3. Oh, maybe C is wrong here. Although I don't think it is. Let's see. Yeah, maybe C is wrong. Maybe my A, B, and C up here are wrong. It's 5, 3.3. So 1600, 900, that's 700. well, basically, it has to be between 30 and 40. By 0.01. Oh, the A. I was looking at this equation. So silly. Thank you so much. Thank you so much. So A is 0.01. I need to multiply that denominator by 0.01. Okay. So now it's this answer, 9.5 9.502550688 divided by 0.02. Okay, no, again, I've messed up. What in the world? Why do I keep making mistakes here? I feel sorry for anyone watching this back. Now what have I done wrong? This is a positive. -4 times -24. That's a positive 96 plus 0.09. Have I? That's fine. Ah, and then I've got to have the A in here as well. Okay. All right. Oh dear, oh dear, oh dear. Okay, so now we have 96 times 0.01 plus 0.09. Take the square root of that. Take 0.3 and then divide that by 0.02. Yes, that looks appropriate. So as I said, it needed to be between 30 and 40 because these stopping distances are 14 and 24. So I'm hoping that this is correct. So I get 36.23 and so on. Feet. Why feet? I don't know. Okay. Alright. That was certainly a challenge for me. Maybe not for you, but that was definitely a challenge for me. So that was the end of the last exercise. And if I got these all incorrect, then I quit mathematics forever. A 0.01, B 0.3, C -4, and the stopping distance, sorry, that was speed. That was speed, not stopping distance. Miles per hour. So I got that wrong because I didn't use the correct units. Alrighty. Well, there you go. So just a quick rundown of that mess of a walkthrough of a question. we had to create lots of different equations. I created 5 different equations in total, then found A, B, and C, and then part B was basically just solving a quadratic. And if I hadn't messed it up, it would have been pretty straightforward. Okie dokie. On to chapter 3. Chapter 3, Equations and Inequalities. After completing this chapter, you should be able to solve linear simultaneous equations using elimination or substitution. Solve simultaneous equations, one linear and one quadratic. Interpret algebraic solutions of equations graphically. Solve linear inequalities. Solve quadratic inequalities. Interpret inequalities graphically and represent linear and quadratic inequalities graphically. A lot of this has actually moved to GCSEs. So previously, before the new specification, inequalities, interpreting inequalities graphically, I don't believe is in there. So that is now in the new specification GCSE. So all of this is already in there, although maybe some of this might be a little bit more complex, but we'll see how it goes. Okay, so some prior knowledge stuff here. Venn diagram question, set notation. So that's the intersection, that's the forgetting what the comma means again. Well, this is the union of A and B something. If you can remember what that comma is, then let me know. Surds, so simplifying surds, we did this in chapter 1. 3, matching the equations to the correct graph. The complement, that's what it's called, the complement of A union B. Thank you. So match the equations to the correct graphs, label the points of intersection with the axes and coordinates of the turning points. So this was actually from the previous chapter. We did some of this. So 9 take x squared. That's a negative quadratic. So it must be upside down, so a frowny face, because the coefficient of x squared is negative. So actually that's the only option there. This one, if we expand it out, would be a positive quadratic. And there's only one option for this because it has 2 factors, meaning we would have 2 solutions for x. You remember what that means? It means there's 2 roots. In other words, the graph crosses the x-axis twice. And then b, well, by process of elimination, b would be number 3. We could also say that if we tried to solve this for y equal to 0, we would get a negative square root, so it would have no solutions or no roots. Alrighty. There's a little note here. Food scientists use regions on graphs to optimize athletes' nutritional intake and ensure that they satisfy the minimum dietary requirements of calories and vitamins. Regions on graphs, so we'll be talking about those. Satisfy the minimum dietary requirements for calories and vitamins. Interesting. I have a hard time believing it would be that precise. I mean, I think they'd probably use the mathematics to guide them, but also there'd be a lot of professional judgment involved there. So it's like that previous section we talked about modeling. It's never exact. You never can get a model to fit exactly. I think it'd be kind of a bit of a approximation and a bit of professional judgment if you're kind of talking about nutrition, considering there's a lot of biology in there as well. Anyways, that's a bit of a tangent. Let's get on with it then. Linear simultaneous equations. what can I say? I mean, I've taught this in to year 9 classes, even to some higher year 8 classes. I'd be hoping if you're doing A-level mathematics, you would be pretty confident at this, I think. I'm not saying if you are not confident with it, that's bad, but I'm just saying I would probably expect, I guess I'm saying I'd be surprised if you said, yeah, I really want to learn simultaneous linear equations in A-levels, but let's see what it leads to. Even inequalities, I mean, we do that in GCSEs as well. All right, let's just speed through this. So here's an example. They are using what for this? They are what have they even done here? They've multiplied it by 3, but they haven't described that in any way. So they're using elimination. They multiplied this second equation by 3. Oh, here it is. So that's the second equation by 3. They subtract them. They get a value for x. They plug it into one of the equations. They get a value for y. The second one here, they multiply equation 1 by 3 and equation 2 by 2 to get 12x in each equation. And solve for y. And then solve for x. Okie dokie. Another example here. They've rearranged the equation in terms of y and then plugged it into the second equation. So that's another way of solving these. Alrighty, let's do a couple from 3a. I'm just thinking, I'm wondering if I'm going to skip some of these at some point because, well, that looks like a fairly interesting chapter. Yeah, maybe I'll skip like some of them. Like I don't really want to do a whole chapter on y equals mx plus c. Anyways, I keep going on tangents. Apologies for that. So, simultaneous equations. Let's do b and e. B is 7x plus 3y equal to 16 and 2x plus 9y equal to 29. So as I was saying, you have basically two methods here. You can either use elimination, which means getting one of the coefficients to be the same, or you can use substitution, so rearranging an equation and substituting into the other equation. Here, because I can see if I multiply the first equation here by 3, I'm going to have 9y in both equations. I'm going to use elimination. So then we get, multiplying this by 3, we get 21x plus 9y equal to 48. And the second equation stays the same, so we're going to subtract that. This is 2x plus 9y equal to 29. And maybe you can see, but one way to remember whether to subtract or add if you have trouble with that is to look at the signs of the coefficients. If they're the same, you subtract, so same sign subtract. And then if they're different, you say add different signs. Anyways, subtracting these two equations, 21x take 2 is 19x, 9y take 9y is 0, 48 take 29, the difference there is 11 plus 8 is 19. So here we get a value for x of 1, That's nice and easy because then we can plug it straight into one of these equations. Let's use this one here. We get 2 times 1 plus 9y equals 29. Then 9y equals 27. And then y equals 3. Okie dokie. Pretty good stuff, right? 3x take 2y equal to negative 6. 6x plus 3y equal to 2. This is my next problem. Again, we could use elimination, but we're going to have to multiply them both. Sorry, multiply the first one by 2. And then we get 6x take 2y equal to negative 6. And we could actually subtract this from the second equation. And we're going to get 6x take 6x is nothing. 3y take negative 2y is 5y. And 2 take negative 6 is 8. So y equals 8 on 5. And then plugging that into one of these, let's use the first equation here. We get 3x take 2 times 8 on 5 is equal to negative 6. What can we do here? Multiply by 5, I guess. 15x take 16 equals negative 30. 15x, maybe I made a mistake here, I'm not sure. Negative 30 plus 16 is negative 14, so x equals negative 14 on 15. And let's go ahead and check these. So this was 3a1. Actually, yeah, why not? 3a1. And of course, we can always substitute them into one of the equations to double check. So we don't really need the answers here. This is kind of me being a little bit lazy, but you know, why not if you have them? So which ones did I do? B was 1, 3. And E was negative 2 on 3, 2. Oh, okay, so boom. That should be 4. And then this should be, no? I only multiplied the x there. Make sure you multiply everything by 2. Don't do this mistake. So this is not a good day for me today. I must be tired or something. So I've multiplied only the x coefficient. You need to multiply everything by 2, of course. And then this becomes 3 plus 4 is 7. And what have I done? 2 plus 12 is 14. And then this is 2. And then we would get a value of x of what? 3 take 4. 3x take 4 equal to negative 6. And then 3x equal to negative 2. And then x equals negative 2 on 3. Okay. Where are we up to? We are up to 2. Looks fairly similar to what we were just doing. Oh, so this one was saying by elimination. They're actually telling us to do it by elimination. This one is by substitution. Okay, so let's just do 1 by substitution. So 2a, we have x plus 3y equal to 11. and 4x take 7y equal to 6. I guess they want us to rearrange equation 1, so this would now become x equals 11 take 3y. We substitute that into this equation, so this will be 4 multiplied by 11 take 3y. We're taking this value for x, substituting in here, take 7y equal to 6, and then we solve for y. So this will be 44 take 12 take 7y equal to 6, and then 44 take 19y equal to 6, then negative 19y equal to negative 38, and then y is equal to 2. And then x would be equal to 11 take 6 would be 5. Hello, hello. Okay, so that's substitution. If you want to do any of those other questions, feel free, and then when I go to the answers again, you can check those as well. Then we have some more complicated ones. So for these, you'll expand out the brackets and simplify, and then you essentially take the same steps as you were before. 4 and 5 look a little bit different. Let's have a go at 4. Let's have a go at question 4. Looks kind of interesting. GCSE level, yes. Yes, yes, yes. So we've got 3x plus ky is equal to 8, and then x take 2ky is equal to 5. It says show that x equals 3. We could either use substitution or elimination. I might use elimination because if I multiply this by 2, then I get 2k as the coefficient of y, and then I'll be able to eliminate that unknown. So multiplying the first equation by 2, the whole thing, not just the x coordinate, the coefficient of x like I did before, this will be 6x plus 2ky equal to 16, and then we want to subtract x take, add, because the signs are different, add 2ky equal to 5. This will be 7x, this is a negative, 2ky take 2ky, they disappear. 16 plus 5 is 21, and then we've shown x equals 3. Okay, so not that interesting after all. I thought this would be a bit different, but it's pretty similar. B says given that y equals a half, determine the value of k. Okay, so if we use that second equation, we would have 3 take 2k times a half equal to 5. So 3 take k, 2 times a half is just 1, equals 5, and then k is equal to negative 2. Okay. Alright, I'll leave question 5 for you to have a go at if you'd like to do that one. Although it is 5 marks, let's just have a read of it and see. So 2x take py equals 5, 4x plus 5y plus q equals 0 are simultaneous equations where p and q are constants. Okay, the solution to this pair of simultaneous equations is x equals q, y equals negative 1. Find the value of p and the value of q. Hello, hello. Alright, if you are here in the live stream, do question 5 or skip. What do you think? Question 5 or skip? You decide. Do. Okay. Alrighty. Thanks to all of you joining in, by the way. I really appreciate having your company. So we've got 2x take py equal to 5, 4x plus 5y plus q equal to 0. And they tell us x equals q, y equals -1. Can we not just substitute these in? So for every x, can we not just say q? So 2q take, or so if we substitute -1 for y, this will be plus p equal to 5, and then 4q plus take 5 plus q is equal to 0. Could we not just do that, or have I done something wrong there? Well, if these are solutions, then surely I can just plug them in, right? And then we have, well, this equation becomes 5q take 5 equal to 0, and then q is equal to 1. And then if we plug that in here, p is going to equal 3. Okay, that was I don't know, pretty straightforward. So I feel like I've done something wrong. Let's see. What exercise is this? 3A. Right. Q equal to 1, P equal to 3. There you go. 5-mark question. What do you think? Do you think that was worth 5 marks? I mean, it's a little bit different to the previous questions, but not that different, really. Anyways. Quadratic simultaneous equations. Limits. Do they talk about limits? No, I don't think so. Let's see, in year 2, maybe they talk about limits? I mean, okay, in terms of the derivative, you talk about differentiation from first principles, and you sort of talk about the limit, but I don't know. Depends what I mean, there's you can go into a lot of detail about limits. But if that was your question, if they actually go into that kind of level of detail, I don't think they do. Okie dokie, we're on to 3.2. Quadratic simultaneous equations. You need to be able to solve simultaneous equations where one equation is linear and one is quadratic. To solve simultaneous equations involving one linear equation and one quadratic equation, you need to use the substitution method from the linear equation into the quadratic equation. Simultaneous equations with one linear and one quadratic equation can have up to 2 pairs of solutions. You need to make sure these solutions are paired correctly. Okay. So solve the simultaneous equations. X plus 2y equals 3, x squared plus 3xy equals 10. Rearrange the first equation in terms of x, plug it into the second equation where the x term is there, and then you have a quadratic that you solve for y, and then you get the matching pairs of solutions for x. Again, this is stuff you do in GCSEs, so nothing new here. Let's get straight into it. Let's do C and D. 1C, y equals 3x, 2y squared, take xy equals 15. Plugging 3x in, we have y already in terms of x, so we can plug it straight into the second equation. We get 2 times 3x all squared, take x multiplied by 3x equal to 15. And if you're not in the practice of putting brackets around what you substitute in, I would encourage it at this stage because it just helps you not to forget to square everything. Right, so if you've got 3x, you remember to square the 3 and the x. Stats and mechanics. Yeah, I'm trying to figure out like how to fit that in at this point, because for me, I want to get through all of this, but it kind of just makes sense to me to work through this all in one go. But I also do want to do some stats and mechanics and kind of fit that in here and there. So I'm not sure. Maybe one day per week I could do stats and mechanics. But yeah. I don't know. What do you think? So this is 9x squared times 2 is 18x squared. 3x squared equal to 15, and then we get actually 15x squared equal to 15. So x squared is equal to 1. So x could be positive or negative 1. Yes, unfortunately stats and mechanics are also mathematics. So x is positive or negative 1. Actually, I haven't finished yet. I need values of y. So y could be negative 3 or positive 3. And now you have to match up the solutions. So the solutions are x equals negative 1, y equals negative 3, and x equals positive 1, y equals positive 3. You actually lose marks if you get that round the wrong way in the exam, so always make sure you're getting the solutions the solutions matched up correctly. And then I said we're doing D as well. 3a plus b equals 8. 3a squared plus b squared equals 28. Alright, so rearranging the first equation, we could rearrange it in terms of b, so this would be, let's label them. Taking the first equation, this would be b equal to 8 take 3a. Substitute it into the second equation. We get 3a squared plus 8 take 3a squared equal to 28. So again, just taking that expression, plopping it right in there. 3a squared plus 64 take 48a plus 9a squared is equal to 28. Expanding those brackets out and then simplifying, I would get 3a squared plus 9a, that's 12a squared, take 48a, and then I have this 64 take 28, so 44 take 8, 36, so plus 36 on the end equals 0. And then we need to solve this quadratic for a. Can I factorize it? Factors of 36, 6 and 6, factors of 12, so I need to make 48. Okay, let's do our little cross thing. If I use 6 and 6 and 3 and 4, is that possible? This would be 18. No, I need 24 twice. So that's not going to work. What if I do 18 and 2? And then what if I do 2 and 6? 36 plus 12, that's 40, that's 48. And then if they're both negatives, this will work. So I can factorize it. This will be 6a and 2a, and then negative 2. So the 6 needs to be multiplied by the 2, so it'll be negative 2 over here and negative 18 here. So expanding this out, we get 12a squared take 36 take 36 take 12 is negative 48a plus 36. So then a equals 3 or a equals 1. Okie dokie. By the way, I have a video on solving quadratic equations, simultaneous equations as well, going through these steps in a lot of detail if you're not confident with this. Okay, so we have a equal to 3 and a equal to 1. Let's find the values of b. B is equal to 8 take 9 is negative 1, or 8 take 3 is 5. So then we have to write down our solutions. Are a equals 3, b equals negative 1, and a equals 1, b equals 5. Okie dokie dokie. They're quite long, aren't they? Quite long and time consuming. Which exercise was this? This was 3b. Oh, so that was the second question I went through. Okay. So that was part 1. I'm not sure what's different about question 2. It looks like there'd be some fractions in here. Yes. No, this one doesn't have any. Okay, so these just look like slightly more complicated questions. Question 3 says solve the simultaneous equations giving your answer in the simplest third form. X take y equals 6 and x y equals 4. We could do it either way around. We could substitute the first equation into the second or the second into the first. Let's just use the first one. We would get x equal to 6 plus y. And then substituting into the second equation, we get x multiplied, we get y multiplied by 6 plus y equal to 4. And then 6y, actually let's write it around the other way. Y squared plus 6y equal to 4. And then y squared plus 6y take 4 equal to 0. Yes, they are flying by. And then we could, so this is not going to factorize, so we could solve this either with the quadratic formula or completing the square. I might solve it using completing the square, so this would be y, mainly because the coefficient of y squared is 1, so it makes it quite easy to do it that way. So this is y plus 3 all squared take 9 take 4 equals 0, and then y plus 3 all squared take 13 equals 0, and then y plus 3 all squared is equal to 13, and then y is equal to positive or negative root 13 take 3. And then we need our values for x. So substituting those into the first equation, we would get x take negative root 13 take 3 equal to 6, and then x plus root 13 plus 3 equal to 6, and then x plus root 13 is equal to 3, and then x is equal to 3 take root 13. This is kind of interesting. I don't think I've done this with surds much before. So just wondering why it was 3. So positive 3 take root 13 of x is negative root 13 take 3. Anyways, we also need the other value of x, so this is x take positive root 13 take 3 equals 6. So x take root 13 plus 3 is equal to 6. Yeah, so x is equal to root 13 plus 3. So here my solutions are y equal to negative root 13 take 3 and x equal to 3 take root 13. This is actually not in GCSE, solving these with surds, I don't believe. So this might be something new. So that's one solution. No. And then the other solution was y equal to root 13 take 3 and x equal to root 13 plus 3. Okay, I want to check that just to make sure I got those correct. This was what? This was 3b. And we can check all of the solutions at this point. Okay, 3b, 1c was -1, -3, and 1, 3. D was A1, B5, and A3, B -1. And what about this one? 3A. 3 plus root 13, root 13 take 3, okay. And 3 take root 13 and -3 take root 13, okay. Awesome, thank you for that. Yeah, they might be in the calculator papers, although I've never seen a question like this with surds, but yeah, I guess it could come up. There's no reason why it couldn't be in there. For sure. Okay, so I'm just going to finish this section and then that will be it for today. And then tomorrow will be 3.3 simultaneous equations on graphs. Why is this 6 marks? I'm really curious as to why this is 6 marks now. What's so difficult about this one? You probably have to solve something with the quadratic equation maybe, or well, or get a surd. I'm curious why that's 6 marks, but I'm going to leave it because it looks just the same as all the others. Question 5, part B is 5 marks, and that has a surd as an answer. So I guess these would be just the same as this example, just maybe slightly more complicated. Question 6 says one pair of solutions for the simultaneous equations is 1p where k and p are constants. Find the values of k and p. Find the second pair of solutions for the simultaneous equations. Alright, so let's have a go at 6 and the challenge, and then that will be it. Okay, question 6. We get y equal to kx take 5 and 4x squared take xy equal to 6. And then we have one solution, 1p. So one solution is x equal to 1 and y equal to p. What does this mean? I guess we could get a value for k here in terms of p. Okay, what I'm wondering is what to substitute for what. So if I get everything in terms of p, yeah, I think that's what I'm going to have to do. So I need everything in terms of p. So get rid of the x's and the y's, and then we can solve for p. So the first equation, actually the first part says find the values of k and p. Oh, yeah, okay. So if x is equal to 1, we can substitute that into equation 2. This would be 4 take p, because y equals p, equals 6, and then p is equal to -2. In other words, y is equal to -2, so then using the first equation we get -2 equal to k take 5, so then k is equal to 3. Okay, then we need the second pair of solutions. So I have k, I have p. So one solution was 1, -2. Oh, and now it's just a traditional question because I have k. So this first equation becomes y equals 3x take 5. This is part B. And then I substitute that into the second equation. So this is 4x squared take x times 3x take 5 is equal to 6. And then 4x squared take 3x squared plus 5x is equal to 6. And then x squared plus 5x is equal to 6, but okay, yeah, and then x squared plus 5x take 6 is equal to 0. Factorizing this is x. Actually, can we factorize it because it's a positive and a negative? Oh, 6 and 1. So if we do positive 6 and negative 1, that should give me positive 5 and negative 6. So here my solutions for x are -6 and x equals 1. We've already considered when x equals 1, so now we have to solve for x equals -6. So using the first equation, we can say y equals -18 take 5. This is equal to -23. Alright, so I guess what I would say about that question is, even though it's worded quite differently and maybe confusingly, it still boils down to the same process, which is nice. And probably I would say, I'm guessing that would be the same situation for 4 and 5. So my solutions there are 1, -2, and -6, -23. Okay, the challenge. What's so challenging about this challenge? Let's see. y take x equals k, x squared plus y squared equals 4. Given that the simultaneous equations have exactly one pair of solutions, show that k equals positive or negative 2 root 2. Right. So the first thing I would say is taking equation 1, y equals k plus x, and then substituting it into the second equation, we have x squared plus k plus x all squared equal to 4, and then x squared plus k squared plus 2xk, actually I should write that as 2kx plus x squared is equal to 4, and then 2x squared plus 2kx plus k squared take 4 is equal to 0. Now what? These are the steps that we generally take, right? We rearrange the first equation, substitute it into the second equation, but this time we have an unknown of k. So how do we solve it from here? Remember from the previous chapter we talked about the discriminant, so I have a feeling that we need to consider the discriminant in this situation. Do you remember when we had one pair of solutions? What was the what did we say the discriminant was? Well, firstly, let's write down the discriminant. It's b squared take 4ac. And we said when there was one pair of solutions, it was equal to 0. So I have a feeling we're going to be able to use this fact in order to help us solve this. So firstly, b is 2k. So this will be 2k all squared. Take 4 times 2, a is 2. And then c is k squared take 4 equal to 0. And then you notice this is going to turn out to be a quadratic, probably in terms of k, and we'll be able to get a value for k. So simplifying this, then we get 4k squared take 8k squared plus 8 times 4 plus 32 is equal to 0. And then negative 4k squared is equal to negative 32, so k squared is equal to 8. Oh, sorry, we haven't finished yet. K squared is equal to 8, and remember it says show that k equals positive or negative 2 root 2. Well, if we take the square root of both sides, we get k equal to root 8, which we can also write as a simplified surd, which we did simplifying surds earlier. This can be written as the square root of, I should say positive or negative, square root of 4 times the square root of 2, which is equal to positive or negative 2 root 2. Okay. I managed to do that challenge without making any mistakes. Unlike the first challenge that I started this stream with. Okie dokie. I'm going to take a short break. That's all that I'm doing from the textbook today. I feel a little bit off today. I don't know if you could tell or not by the amount of mistakes that I made. I'm going to take a short break and then I'll be back to take any questions if you have them. Hardest easy geometry problem. I don't know. There is a popular one on YouTube. It's like pretty much every maths YouTube channel has done this problem. Like I keep seeing it on every single one. It's like a geometry problem with some angles. You have to find the unknown angle, but I don't remember exactly how it goes. Prove that 1 plus sine x on cosine x equals sine x take cosine x over sine x plus cosine x take 1. Whew. Sine x plus 1. Going to say this looks difficult, but I could be wrong. Yeah, I was wondering which side to start with, the left or the right. You might be right. Starting with the left could be helpful. Let's just go with the right hand side. I just want to write it slightly differently. I've got it. I figured it out. We just cancel that. And then we're done. Alright, so let's separate it. Whoa, why is that so loud? Apologies for the... I have no idea what happened there. What in the world? I hope that wasn't too loud. Hey. Is linear programming covered in A-level mathematics? I don't think so. Alright. So let's write this as two fractions. And now what? Not sure what I'm doing. What else can I try? What do we get with the left-hand side? This is 1 on cosine x plus sine x on cosine x. Yes. Sec plus tan. There's probably some identity that... can't think of. I'm hopeless at remembering trig identities. What about 1 plus sine x is equal to sine squared x plus sine x plus cosine x? This is sine x plus 1 plus cosine x. It doesn't help, I don't think. Unless you separate that. Multiplied by the conjugate. I don't want to do that. Which one? The right hand side by the conjugate? What would that even be? Cosine plus sine plus 1? Why not? Has a question. Alright, I'll get onto that after this one. That's not helpful. I don't know if the secant and the tangent help me. What if we separate this one out as well? Would that do anything? Let's see. Ah, wow. Yeah. Yeah, that's what I said. Take plus 1. Alright, I'll try that next. I'm just going to separate this one out. So this will be 1 over cosine x plus sine x, take 1, plus sine x over... I mean, I could have done this straight away. I didn't need to do the middle step. Does that help at all? I don't think it does. don't think it does. Alrighty. So the question is which one? So let's try multiplying this one by cosine x plus sine x plus 1. Or even this step. Okay, maybe this step. There must be another way to do this, surely. This would be cosine squared x plus sine x cosine x plus cosine x all over cosine cosine plus sine x all squared. First outers plus 2 lots of cosine x plus sine x. Oops. Take 1. Why? Why? I was meant to do this one, not this one. Yeah. Okay, so I'm going to put this to the side for now. Hello, AJ Maths. Maybe you can help us out. With this identity. Oops, I still have that thing on. So if we take the right hand side, actually let's write it like 1 plus sine x take cosine x. No, let's keep it as is. And then multiply by the conjugate. So this would be sine x plus cosine x plus 1. Okay. Now let's see what we get. This is going to be so long. Let's get rid of this junk. Didn't need that. Then we have plus sine x, take cosine x, plus, oh no, yeah, plus sine x plus cosine x plus 1. On the bottom, we have sine x plus cosine x all squared plus 2 lots of, no, sorry, they cancel out. So positive sine x plus cosine x takes sine x plus cosine x, and then a negative 1. Okay. Then what? Then what? I guess try to simplify the numerator. So this would be sine squared x take cosine squared x plus sine x take cosine x plus sine x plus cosine x plus 1. Oh boy. Over sine squared x plus 2 sine x cosine x plus cosine squared x, take 1. I need to use some kind of identity here, I think. Okay, what can we cancel? That disappears. Then we have sine squared x take cosine squared x plus 2 sine x plus 1. What do we need? We need plus sine x over cosine x. This is a random question from Philic. Okay, I'm pretty sure I simplified all of this correctly. Hopefully I didn't make any mistakes. Let's see. So I have a negative cosine squared. I could substitute sine squared take 1 in there, but I don't know if that helps me. Oh, can I not? No, I was going to say, can I factorize these? Yeah, that's what I've done so far. Okay. Oh. Your denominator is slightly different. Oh wow. Oh wow. Huh. Here we have 2 sine squared x. Oh, we've got there. We're going to be able to cancel a 2 sine x. Wowee. That was pretty amazing. Alright, I couldn't think out any of that out loud while I was doing it. Nice problem. Nice, nice, nice. Nice, nice, nice. So firstly, multiply by the conjugate, which is not something I would have thought of, I don't think. Simplify. Here, I substituted cosine squared x take 1 for negative sine squared x. Yes, finally I got there. And they cancelled out. Oops. These cancelled out. So then I'm left with sine squared plus 2 sine x take cosine squared plus 1 over 2 sine x cosine x. Then I substituted sine squared for the 1 take cosine squared. Then we have 2 lots of sine squared x plus 2 sine x. Factorize out 2 sine x, cancel, and you're left with sine x plus 1 over cosine x. Pretty cool problem. What I like about that one is that you don't need really any complicated identities. This is the only identity you needed for that problem. But this step, that's a hard one to see. Multiply by the conjugate. Never would have thought of that one. Where did you get that problem from, Philip? Wowee. Next live stream will be tomorrow. And I usually try to start at 11 AM, although I'm usually late. From the school book. Cool. Cool, cool, cool. I don't think I did get your email. Let me just check my junk folder. Sometimes they go to junk for some reason. Nope. Let's see. Yep, it went to my spam folder for some silly reason. So how do I not spam? There we go. Yes, so I've got it now and I'll get back to you after this. Alright, does anybody have any other? Oh, there was one other question somebody had. Who was it? Why not? I'm not sure if you're still there or not. Why not? So, this was the question. I have a... actually, there was another part to it. End of year 10. So, an investor invests £2,000 on January 1st every year, so at the start of every year. Hmm. 4%. The interest rate is 4%. If the interest is calculated on the 31st of December at the end of the year, so interest is calculated at the end of every year, and it was find the find the amount at the end of 10 years. Okay, so let's just do a couple of years and see what happens. So at the end of the first year, we would have 2,000 times 1.04, and then he invests another 2,000, and then that is multiplied by 1.04 at the end of the next year. Then he invests another 2,000, and that whole thing is earns interest of 4%. Just wondering, how could we simplify this? Is there a nice neat formula? So 2,000 times 1.05 to the 10, that would be if it's just compounding for 10 years, but you also have to consider he invests the 2,000 each year. So there's a bit of an added complication. Let's see. Although it could be that simple. This would be the first 3 years. Yeah, so you get a sequence. Right? If you expand out, so this was the first year. This was the second year. And the whole thing was the third year. If we just expand out those, we get 2000 times 1.05 cubed plus 2000 times 1.04 squared plus 2000 times 1.04. If we kept doing this, you can imagine what we might end up with at the end. Basically, we're multiplying, well, we're raising the power of 1.04. Yeah. Yes, so that's the compound interest formula for just one amount invested at the start. This question is £2,000 invested at the start of every year of the 10 years. So what you end up with is that 2,000 compounded for 10 years, plus 2,000 compounded for 9 years, plus 2,000 compounded for 8 years, and so on. Which we could write another way. Guess this is an easier way to write it. And so each term is increasing. So is it an arithmetic, or I get the feeling it's a geometric sequence because we're increasing each term by 1.04. So then we could use the sum of a geometric series. And that is in the formula booklet. That formula. Which I'm going to pull up because I don't remember what it is. Here it is. So A is the first term and R is the difference between each term. So A is equal to 2000 times 1.04. R is equal to 1.04. And N is equal to 10. So let's give this a try. let's write this down. A 1 take r to the power n over 1 take r. This is equal to 2000 times 1 take 1.04 to the power of 10 over 1 take 1.04. This seems like a fairly classic geometric sequences question. And hopefully I've got it somewhat correct, but we'll see. Take 2000 multiplied by 1.04 to the power of 10 divided by negative 0.04. Seems like I'm a bit off. Would the first... Oh, I've put the first term in incorrectly. This should be 2000 times 1.04. I don't know if that's going to make any difference. There we go, yeah. So, as usual, just entered something in the formula incorrectly and got the wrong answer. Alright, so final answer there. 24,972.70. Nice one. This is probably where this kind of geometric sum, you know, where it all started, problems like this, where someone's you know, investing money in an account over a number of years and also compounding the interest, and you end up with this geometric series. Cool. All right. If anyone has any other questions, feel free to post them. Otherwise, I am going to head off. Thank you. It's geometric series sequences. This is an A-level topic. You could figure it out without that. I mean, you could just like sum all these up, calculate them all, sum them all up, and you get an answer. I guess this is just a shortcut, really. Like using this formula is just a shortcut. And this is the sum that it works out. 2000 times 1.04 plus 2000 times 1.04 squared, and and so on, all the way up to 2000 times 1.04 to the power of 10. Alrighty. If you want to tune in tomorrow, I'll be on then. Hopefully see you then. Bye for now.